Ray optics question 1. A ray of light is incident on a plane mirror at an angle of 60 degree. What is the deviation produced by the mirror? Over here they are telling us, they are asking for deviation and they have given us the incident I. We'll use the formula for deviation, which is delta is equals to 180 minus 2 times the incident. Incident I is already given to us, that is 60. Therefore, we have deviation is equals to 180 minus 2 into 60, which is equals to 180 minus 120, that is 60. Option B. Question 2. Two plane mirrors are inclined at an angle of 60 degree. An object is placed between the mirrors. The number of images formed by the mirror is. Let the number of images be n. We have the formula as 360 upon 60. The 60 is given upon 60, which is 6. Over here my n is an even number. Number of images n is my even number. So we have to do n minus 1. That is 6 minus 1. That is 5. Option C. Question 3. An object is placed at a distance of 30 cm from the pole of a curved, convex or concave mirror of focal length 15 cm. Over here they have given the object is placed at the distance of 30 cm and the focal length is 15 cm. So this will be twice the focal length. Then the linear magnification is. Now over here the magnification, they have asked for magnification M. 1 for both types of mirror. Both types means convex as well as concave. But we know that for a convex mirror, it is always, the magnification is always less than 1. Thus A will not be right because 1 for both types of mirror. For a convex it can never be 1. B states 1 only for convex mirrors. Again, convex and 1 can never go hand in hand. C states 1 only for a concave mirror and D is 1 by 3 for a concave mirror. So we have to choose between two options C and D. Both are to the concave mirror. Now let us put the formula M is equals to V by U. Over here my V is 2F, twice the focal length. Even my U is twice the focal length. So 2F upon 2F is 1. Therefore my magnification is 1 for a concave mirror and thus this coincides with the answer C. Question 4. A concave mirror of focal length 15 cm forms a virtual image having twice the linear dimensions of the object. What is the distance of the object from the pole? A 45 cm, B 35 cm, C 25 cm and D 7.5 cm. So over here we know it is a concave mirror. Concave mirror is a mirror which will have more magnification, and since it has more magnification, the U, that is the object distance, is always less than F, that is my focal length. The given focal length is 15 centimeters. Thus my U should be less than 15 centimeters. A, B and C are 45, 35 and 25 respectively. All three of them are greater than 15 centimeters, that is greater than the focal length. Hence my correct answer will be D. Question 5. A spherical mirror forms an erect image of magnification 3. What is the object distance if the focal length of the mirror is 24 cm? A 24 cm, B 16 cm, C 32 cm only and D 16 cm only. So over here we have a spherical mirror, but in this they have told us that a magnification is 3. When a magnification is 3 times the original image, it has to be a concave mirror. So this spherical mirror is basically a concave mirror. So in concave mirror the focal length is negative. It is given as 24, so we will take it as minus 24. Now, using the formula M is equals to F upon F minus U. We have M as 3 is equals to minus 24 upon minus 24 minus U. that is equals to 24 upon 24 plus u. We have 3 is equals to 24 upon 24 plus u. Solving this, we get u is equals to minus 16. Thus, our answer is 16 centimeter only. Question 6. The focal length of a convex lens is 30 centimeter and the size of the image is quarter of that of the object. What is the distance of the object from the lens? A 90 centimeter, B 60 centimeter, C 30 centimeter, D 50 centimeter. So over here, F is given as 30 centimeters. And we have been given that V is U by 4. So now by using the formula, we have 1 by F is equals to 1 by V minus 1 by U. Therefore, 1 by U would be 1 by V minus 1 by F. We have just shifted 1 by U on the opposite end. Now we have V as U by 4. So we'll substitute the value of V over here as U by 4. So 1 by U will be 1 upon U by 4 minus 1 by F. So 1 upon U by 4 will be 4 by U. Therefore 1 by U is equals to 4 by U minus 1 by F. Substituting the values, we get 1 by U minus 4 by U is equals to minus 1 by 30, because over here F is given as 30 centimeters to us. Now solving this, we will get U is equals to 90. That is option A. Question 7. A luminous point object is placed at a distance of 20 centimeter from the pole of a convex spherical surface of glass. The radius is 25 centimeter and the RI of the glass is 1.5. What is the distance of the image from its pole? A. V 20 centimeter in glass. B. V 30 centimeter in glass. C. V 30 centimeter in air. D. V 40 centimeter in glass. So over here we have U as minus 20 centimeter. R is 5 centimeter. N1 is taken to be 1 because of air and N2 is given to us as 1.5. Using the formula N2 by V minus N1 by U is equals to N2 minus N1 by R. Now we will substitute the values into this. N2 is 1.5 by V, N1 that we have considered 1 because of air is 1 by U is equals to 1.5 minus 1 upon R. 1.5 minus 1 is 0.5, which can be written as half, and R is 5. So we get this as 1 by 10. Therefore 1.5 upon V is equals to 1 by 10 minus 1 by 20, which boils down to 1 by 20. V will be 1.5 into 20, that is 30 centimeters, and since it is not negative, it is positive, it will be in air. So C. Question 8. How far from a convex lens of focal length 20 centimeter will you place an object to get a real image enlarged 3 times? A 15.6, B 20.5, C 26.66, D 33.85. Okay, so now over here they have told us that the magnification is 3 times. When we have magnification 3 times, we consider that the lens is a concave lens. So M over here is 3. The lens is concave. When the lens is concave, the U has to be negative. Considering U as negative X, we have V is equals to, we have M is equals to V by U. Correct. So over here, we'll have V is equals to MU. You just multiply this over here. We have M as 3. Therefore, V will be 3 times U. U is X. Therefore, V is equals to 3X. So now we have the values of U. We have the value of V. Using the formula, 1 upon V minus 1 upon U is equals to 1 upon F. We have 1 upon 3x, which comes from here, minus 1 upon minus x, because u is minus x, is equals to 1 by f. F is my focal length, which is given as 20 centimeters. Therefore, 1 upon 3x plus 1 upon x minus will become positive, is equals to 1 by 20. Solving this, we get 4 upon 3x is equals to 1 by 20. Therefore, 3x is equals to 80 and x is equals to 80 by 3, which is equals to 26.66. We have found that x is 26.66 and we have considered u as minus x. Thus, we will have value of u as 26.66, option C. Question 9. If the radii of curvature of the two surfaces of a concave lens are 10 cm and 20 cm respectively, and the refractive index is 1.5, what is its focal length? A minus 10 cm, B minus 12 cm, C minus 13.33 cm, D minus 16.25 cm. So over here we have a concave lens with two radii, that is 10 and 20. So let's take R1 and R2 as the two radii. Since it is the radii of a concave lens, R1 will be minus 10, R2 will be 20. Now we can use the formula 1 by f is equals to n minus 1 into 1 upon R1 minus 1 upon R2, which is equals to 1.5. N is 1.5. It is given in the question. 1.5 minus 1 into 1 upon minus 10 minus 1 upon 20. 1.5 minus 1 is 0.5, which can be written as half, that is 1 by 2, is 1 upon 10 plus 1 upon 20. Solving this, we get 1 by f is equals to minus 3 by 40. Therefore, f is equals to 40 by 3 minus 40 by 3, which boils down to minus 13.33 centimeters. That is option C. Question 10. An object is placed at a distance of 30 cm from a concave lens of focal length 15 cm. What is the height of the object if the height of the image is 3 cm? A 3 cm, B 1 cm, C 6 cm, D 9 cm. So over here they have already told us that we have a concave lens. Concave lens will have f and u both as negative, and these f and u are given to us. F is minus 15, u is minus 30. Using 1 by f is equals to 1 by v minus 1 by u, we can find out the value of v. Therefore, 1 by v will be 1 by f plus 1 by u. Substituting the values of f and u, I get minus 1 by 15 minus 1 by 30. Solving this, we will get the value of 1 by v as minus 3 by 30, which is equals to minus 1 by 10. Therefore, v will be minus 10. Over here, I have got v as minus 10. I know magnification is v by u, which is equals to minus 10 by minus 30. Minus minus cancel. This is 1 by 3. V is for the image, whereas u is for the object. So image upon object. Therefore, I will get object is equals to 3 into image, which is equals to 3 into 3, which is 9. The answer is D. Question 11. A long glass rod has a hemispherical end. A narrow beam of light is incident on the spherical end. The beam being parallel to the length of the rod, what is the position of the image formed if the refractive index of the glass is 1.5 and the radius of curvature of the spherical surface is 10 cm? A. V is 30 cm in air. B. V is 20 cm in air. C. V is 30 cm in glass. D. V is 50 cm in glass. So now we have a parallel beam Since it is parallel, my u will be minus infinity and my r will be positive. So this is my rod and there is a parallel beam inside it. Using the formula N2 upon V minus N1 upon U is equals to N2 minus N1 by R, we have to substitute all the values. 1.5 upon V, 1.5 is the refractive index given, minus N1, N1 is of air, that's why we take 1, upon minus infinity, instead of U we take the value of minus infinity, is equals to 1.5 minus 1 by 10. 1.5 minus 1 is 0.5, which can be written as half. So I get 1 by 2 into 10, which is equals to 1 by 20. Therefore 1.5 upon V is equals to 1 by 20. Solving this, we get 30 centimeters. It is 30 centimeters from the pole. Therefore we get V is equals to 30 centimeters in glass. Option C. Question 12. An equiconvex lens has a focal length f. It is cut into two equal parts along the dotted line as shown in the figure. What will be the focal length of each part? So we have R1, R2. So let this be my R1, let this be my R2. Now moving to the options, A f, B 2f, C f by 2, D f by 3. So here let R1 equals to R2 be R. Okay. Now using the formula 1 by f is equals to n minus 1, 1 by r plus 1 by r. We get this as 2n minus 1 upon r. 1 by f is 2n minus 1 upon r. Therefore f will be r upon 2n minus 1. This f is of the entire lens. Now when we cut it into two parts, each becomes a plano-convex lens for which R1 will be R, but R2 will become infinity. If R2 becomes infinity, 1 upon R2 will be 1 upon infinity, and 1 upon infinity eventually boils down to 0. So now for the half-cutted lens, let's keep it as 1 upon f dash is equals to n minus 1 into 1 upon r, because we are not considering 1 by r2 because it is 0. So this is n minus 1 upon r. Therefore f dash will be r upon n minus 1, which is equals to 2. We multiply and divide it by 2, r upon 2n minus 1. Now this r 2n minus 1 is nothing but f. So which is equals to 2f. Therefore f dash is 2f. Option B. Question 13. In the displacement method, the lengths of the images in two positions of the lens between the object and the screen are 9 cm and 4 cm respectively. What is the length of the object? A 5 cm, B 6 cm, C 12 cm, D 24 cm. Over here length L1 is given to me as 9 cm. Length L2 is given to me as 4 cm. If L1 and L2 are the lengths of the image in the two positions of lens between the object and the screen, then the length of the object L is given by the formula root of L1 into L2, which is equals to root of 9 into 4. We have substituted the values of L1 and L2 respectively, which is equals to root 36, which boils down to 6. Option B. The focal length of a convex lens will be minimum for A. blue light, B. yellow light, C. red light, D. green light. Over here we are talking about a focal length of the visible light rays. So the ultraviolet rays or the infrared rays are not visible. The visible light rays can be termed as VIBGYOR, the range of colors which are visible to human eyes. Over here 4 options are given to us: blue, yellow, red and green. So N of blue will be greater than N of yellow, then n of green will be greater than n of yellow will be greater than n of red. Since n of blue is the highest, the focal length of the blue light will be minimum. Thus, option A. Question 15. An index pin of height 3 cm is kept at a distance of 15 cm from a convex lens of focal length 10 cm. The image is obtained on a screen placed on the side of the lens. What is the height and nature of the image? A. 3 cm erect, B. 6 cm erect, C. 6 cm inverted, D. 1.5 cm inverted. Okay, so over here we'll start solving. We have F given as plus 10 centimeters, U as minus 15 centimeters. The minus is because of the type of lens it is. Thus it is giving us a magnified image. It will be a concave lens, and since it's a concave lens, the U will have a negative sign. Using the formula 1 by V minus 1 by U is equals to 1 by F. We have to find V, therefore 1 by V will be 1 by F plus 1 by U. This has gone on that side, the negative becomes positive, which is equals to 1 by 10 plus 1 upon minus 15. Minus and plus becomes minus, so 1 by 10 minus 1 by 15, which is equals to 15 minus 10 by 150. Solving this, we will get as 1 by 30. 1 by V is 1 by 30. Therefore, V will be 30. Okay, now magnification is equals to V by U, where V is for the image and U is for the object. So, I by O, which is equals to 30 by 15, which is equals to 2. The height of the image will be 2 times 3, because it is already 3 centimeters, that is 6 centimeters. As it is a real image, it will be inverted. So it is 6 centimeters inverted, option C. Question 16. The lower half of a convex lens is painted black. If an object is placed in the front of the lens, then A. The lower half of the image will disappear. B. The upper half of the image will disappear. C. The intensity of the image will be reduced to half of that due to the full transparent lens. D. The size of the image will be half of that of the size of the object. Over here we have a convex lens. This is a convex lens which is bulging from both the sides. Half of the convex lens is painted black in color. So now only the upper half of the lens is there. Thus the intensity of the lens, or the effective surface of the lens, will also be half of what it was before. Since it is half of what it was before, the size of the object will also be halved. Therefore, the size of the image of the object will also be halved. Thus, we will have the size of the image will be half of that of the size of the object. That is option D. Question 17. An eye specialist prescribes spectacles having a combination of a convex lens of focal length 40 contact with a concave lens of focal length 25 centimeters. What is the power of the combined lens? A. 1.5D, B. minus 2.5D, C. minus 1.5D, D. plus 2.5D. First over here, we will find out the power or a convex lens. So that will be 100 by 40, because it is 40 centimeters given, which is equal to 2.5D. Similarly, we will find out the power of a concave lens, which is 100 upon minus 25, minus because it is concave and 25 is given. So this becomes minus 4D. Now, this is a bifocal lens with a combination of both convex as well as concave. So the total power will be power of convex plus power of concave, which is equals to minus 4 plus 2.5, which is equals to minus 1.5D, option C. Question 18. Two lenses with pass plus 12D and minus 2D are kept in close contact with each other. Find the par of the focal length of the combination. A 12 cm, B 10 cm, C 8 cm, D 15 cm. So your two lenses are there. The par of one is plus 12D, plus means it must be a convex lens, and P2 is minus 2D, stating that it must be a concave lens. My total par will be P1 plus P2, which is equals to 12 minus 2, which is equals to 10D. Now P is equals to 1 by F. This is the formula. Therefore, F will be 1 by P, which is equals to 1 by 10. But this is in meters, 1 by 10 meter. 1 by 10 meter boils down to 10 centimeters. Option B. Question 19. A convex lens and a concave lens, each having same focal length of 25 centimeter, are put in contact to form a combined lens. What is the par in diopters of the combined lens? A 25, B 50, C infinite, D 0. Okay, so now we have a combined lens. Par is always P1 plus P2, where P1 will be either of concave or convex and P2 will be the other. But over here, we are supposed to find a focal length. So, P is 1 by F. Therefore, 1 by F is equals to 1 upon F1 plus 1 upon F2. Over here, F is given as 25. So, F is 25, but it will be positive 25 for convex and negative 25 for concave. Substituting the values, let's consider F1 to be convex, so we get 1 by 25, and F2 to be concave, so we get negative 25. This will be 1 upon 25 plus and minus 1 upon 25, which is 0. Option D. Question 20. An achromatic combination of lenses is to be made by using a convex and a concave lens. The two lenses should have A equal pars, B equal refractive indices, C equal dispersive pars, D the product of their pars and dispersive pars equal. So over here we are talking about F1 and F2, there are two focal lengths. They are equal to W1 upon W2. These are my dispersive pars. We have P is equals to 1 by F. Therefore, P2 upon P1 will be W1 upon W2, since they are inversely proportional to each other. Therefore, P1 W1 will be equal to P2 W2. This is the mathematical form of this statement. The product of their pars and dispersive pars equal. Option D. Question 21. A convex lens of a glass has par P in air. If it is immersed in water, par will be A more than P for some colors and less than P for other colors, B P, C less than P, D more than P. We know that P is equals to 1 by F. P is inversely proportional by F. So when it is immersed in water, the F will increase. If F increases, the P has to decrease than what it was originally. Therefore, the new P, that is the P for water, will be less than the original P. Option C. Question 22. Myopia is corrected by using A. Bifocal lens, B. Concave lens, C. Convex lens, D. Cylindrical lens. So myopia is basically a state in which the far away objects appear blurry to the person. So a person having myopia can use a concave lens to solve it. Question 23. Hypermetropia or long-sightedness can be corrected by using A. Bifocal lens, B. Concave lens, C. Convex lens, D. Cylindrical lenses. Hypermetropia is a condition in which the light cannot focus on the retina of the eyes. It can be corrected by using convex lenses, option C. Question 24. A cylindrical lens is required to correct A. Myopia, B. Hypermetropia, C. Presbyopia, D. Astigmatism. For myopia, we use a concave lens. For hypermetropia, a convex lens is used. For presbyopia, there is a bifocal lens used. But a cylindrical lens is used for astigmatism. Astigmatism is a state in which there is imperfection in the curvature of the eyes. Option D. Question 25. The magnifying power of a simple microscope can be increased if we use a lens of A. Higher focal length, B. Smaller focal length, C. Larger diameter, and D. Smaller diameter. We have P is equals to 1 by F. Therefore, P is inversely proportional to F. Thus, we can increase P if we decrease F. So, the option is B. Smaller focal length. B is the correct option. Question 26. A simple microscope has a magnifying power of 4.125 when the image is formed at a distance of distinct vision. What is the focal power of lens? A. 8.5D, B. 12.5D, C. 14.5D, D. 10.5D. Over here, MP is given to us as 4.125. Using the formula of MP as 1 plus P by F, we will substitute the values. MP is 4.125 is equals to 1 plus 25 by F. Therefore, F will be 25 upon 3.125 because this will go over here. So, 4.125 minus 1, which is 3.125, which is approximately equal to 8. P is equals to 100 by F, which is equals to 100 by 8 because F is 8. 100 by 8 is 12.5D. Option B is the correct answer. Question 27. The MP of a telescope is high if the MP of the telescope should be high when the O is large and the E is small. So we'll see which of the following options match it. A. Both O and E have large focal lengths. Both should not have large, only O should have large. B. Both O and E should have small focal lengths. No. C. O has a large focal length and E has a small focal length. This seems correct. And D. O has a small focal length and E has a large focal length. No. This is completely opposite to the answer. Option C is correct. Question 28. The focal length of the eyepiece of an astronomical telescope is 6 cm. What is the distance between the objective and the earpiece if it produces a magnification of 10 for normal adjustment? A. 36 cm, B. 46 cm, C. 56 cm, D. 66 cm. So here they have given us FE, that is 6 cm. Using the formula M is equals to FO upon FE, we can find the value of FO. Therefore, FO will be, this goes up, M into FE, which is equals to 10 into 6, which is equals to 60. Now, the distance between the two lenses will be FO plus FE, which is equals to 60 plus 6, 60 that we have found, and 6 was already given. So, that is 60. Question 29. In a compound microscope, the intermediate image is A. Virtual, erect and magnified, B. Real, inverted and magnified, C. Real, erect and magnified, D. Virtual, erect and diminished. In a compound microscope, the extremely short object is kept just beyond the focal point. So, we have a focal point of the objective. The objective forms a real, magnified and inverted image. So, we will have to find out the options which have real, magnified and inverted image. This is the intermediate image and it acts as an object for the eyepiece. Real, magnified and intermediate image. We have it in option B, real, inverted and magnified. Option B is the correct option. The magnifying power of the eyepiece of the compound microscope is 6 and the combined magnifying power of the microscope is 84. What is the magnifying power of the objective? A 10, B 12, C 14, D 16. So I have ME, that is magnifying power of the eyepiece, as 6. I have the combined magnifying power as 84. By using the formula M is equals to MO into ME, we can find MO. So MO will be M by ME, which is equals to 84 by 6, which is equals to 14. Option C is the correct.